Okay, so this is the first video in a what's possibly a series or just a long single video showing off my latest project. This is a pole mount GPS receiver and time base or reference frequency standard, whatever you want to call it. And the cool thing about this is that it's a multi-GNSS receiver from U-Blocks fitted in a pole mount enclosure right here with fiber optic I/O. And there's going to be an indoor unit. I'm currently in the process of finishing the outdoor unit, and then I can start working on the indoor unit once that's approximately done. And currently we have it set up here in a test setup. I'm still missing some parts, so not all the functionality is actually there. But what I am able to do right now is to transfer the reference frequency generated in this GPS receiver over fiber optics to this mock-up of the indoor unit right here. And we're gonna go ahead and take a look at each of these components in turn, and hopefully not too long, I'll have some of the more interesting components operational. So why don't we start by taking a look at the indoor unit, or the what you might call the fiber optic receiver. That's this portion right here. Okay, so this is the indoor unit mock-up. This is one of the boards that's inside the outdoor unit, and I think I'm just going to use this. I was thinking of making a custom variant of this board, but I had to build two of them to test the one. These boards talk to each other over fiber optics, as you can probably see. So what's going on here is I've got two 30-pin FFC connectors. They each carry 4 LVDS pairs in each direction, so there's 8 pairs on each of those 30-pin FFCs. And on the back there's all the line filtering and an actual LVDS interface ICs. And what we got here is a level shifter, shifting the output from the SerDes from 2.5 to 3.3 volt logic. And then this is the actual SerDes. This is a Texas Instruments TLK 1501, which is a pretty old IC, but I happened to buy about 10 of these a couple of years ago, around the same time I got those fiber optic transceivers. So I figured may as well use it. An FPGA would be a better choice, really, for this. It would be much more compact, but then I'd have to buy an FPGA and FPGA dev tools. And that SerDes and this SFF module here is basically free, so that's a pretty good reason to use it, if you ask me. The actual SFF here is an old Hitachi unit, originally designed for fiber channel at, I believe, 4 gigabits. Or it might have been 2 or 4 gigabits. Currently it's going to be running at around 600 megabits, which is on the lower end of what the SerDes can handle. But that was a convenient frequency to, or baud rate to use, because it's 20 times the reference output frequency of the GPS, so I can just use that directly to drive the SerDes. I've got a quick breakout here. You can just buy these boards on eBay. They break out FFC connectors to 0.1-inch headers, and I'm using that right now to feed in a reference clock for the SerDes, which I'm generating on my RF generator, and I'm also using it to measure the output from the GPS clock, which is also available. So basically I'm transferring the frequency standard portion of this setup by using the SerDes. I'm feeding the reference frequency in as the gigabit transceiver clock, and then on the other end I can there's a PLL in the SERDES that locks onto that and gives you the frequency out again. So I can use that in principle directly, but I will have to convert it to a more common frequency for lab equipment. It currently runs at 30.72 megahertz, and that's the default, and I assume that's a common base station frequency or something like that. But it's not very convenient for me. Fortunately, it does add up pretty nicely with that, like you can just use an integer n PLL and discipline a 10 megahertz crystal, for example, if that's what you want. There's not a whole lot more to say about this this indoor unit SERDES thing at this time. So I think we're going to go ahead and take a look at the GPS module next. Okay, so this is the actual GPS receiver module. It's a pole mount unit. I've just disconnected the power here so you can see it. And on the base here we have 3 set screws approximately 120 degrees apart to within the closest, you know, by eye, slightly nearsighted eye. I've got helicoils in there. Originally there was like a plastic piece in here, but the issue is when you're trying to put a connector in the base here, it's kind of an issue. This is barely right. Sorry about that. Left my ham radios on. Local repeater opening there. So what you're seeing now is basically just a shielding plate. It's partially shielding, partial sort of slightly distant ground plane for the antenna. I'll show you the radome, I guess. It goes on like that. There's screws on the bottom, as you can see. And the antenna is in here. This is not the final antenna. This is an antenna that I'm going to be using until I get the final one, which should be not too long. But this is what was originally in there. This mounting method is not original. It used to be, you can see there's little plastic pegs poking through there. They used to just melt these down in a couple of locations, and that was your mounting. But this is now removable. And I've ordered a new antenna. This is GPS L1 only. This final antenna is going to be GPS and GLONASS, and it'll probably do Galileo as well to an acceptable degree, but couldn't get multi-system antennas easily. So that's the radome. And back to this thing. What you can see here are single mode fibers. Just run off to the indoor unit over there, as you can see. And I'm not sure how I'm going to waterproof these. I don't think they need that much. Obviously these fibers are not going to be used. I've got some better quality, you know, steel reinforced, more waterproof fibers for the final install. And I just spliced these from pigtails to do my test here. So this is a piece of ABS that I cut with just a paper template, and I decided to use it as my slack take up for the fibers as well. Just got some M2 screws here, M2.5, and let's see. Need to remove this to gain access to the rest of the unit. Let's see. There we go. This is the pretty much the final setup for the electronics package. You see there are these, there's room for like 3 units in here, and originally the GPS, the old one, used to be here in a big rubber insert, and then there was a line driver board over here. What I've done is I've more rigidly mounted them, and I'll take this apart piece by piece so you can see it. You got the SerDes board here. This is identical to the indoor unit. They were built at the same time. So it has the same issues with not having a functioning SerDes currently, just clock. The actual GPS board is this one, and this uses the u-blox LIA M8F receiver, which is a GPS, GLONASS, and Beidou, 2 systems simultaneous GNSS receiver with a built-in VC-TCXO, and that's basically our frequency standard. It has holdover as well, and it actually maintains performance pretty good. Like on cold startup, it's within billionths of correct frequency. So that's quite good. And there's an FFC here that is also LVDS. All my interboard connections in this part are LVDS for high-speed differential transmissions. That includes the clock as well. That's mainly why I went to LVDS instead of RS422 as the lower power consumption at high frequencies. So we got 5-volt power here from the power board at the back, which we'll probably look at last. Let's see. The final antenna is an MCX connector, so I've used that here as well. And I kind of have to pry these out. There we go. That's our board. Just do the FFC. And I'll bring you back for a close-up. The other boards just pull out as well. Oh, stand by. Okay, so this is the GPS module. It's on its own little carrier board. There's not much on the back, just passives basically. 1 or 2 actives, but nothing much. The actual GPS receiver here I just bought directly from u-blox. They'll actually ship to individuals, no problem. They ship it by DHL, so it's a little expensive, but Chinese versions of these are usually fake. I mean, they work, but they're not legit. They don't actually have all the features the model number would suggest. So there's the module. There's no microcontroller on this board. We have the antenna input. This went through a bit of a revision. I was initially going to use a passive antenna, so I had a limiter and a preamp and so on, but I've just bypassed that. There used to be an MMIC right there and a limiter here, and I've just lifted the diodes. And I had a UFL connector here, but that's a really bad choice for my application. It really tends to pop loose when putting the radome on over here during my testing. So because I went with an MCX, I've got an MCX cable just soldered to the board here and then epoxied at roughly the appropriate angle. All the signals to and from the module go to these LVDS drivers and receivers. There's some LEDs, there's transmit receive LEDs, as well as a pulse per second LED. That's 1/2 Hertz. So on the back there's a divide by 2 IC. So every time there's a pulse, this changes state. That just lets you quickly see what's going on. Also got common mode chokes on all the LVDS lines. Power is either via FFC or via this 2-pin 0.1-inch header, and that's how I'm powering the SerDes board, is via the FFC cable. Power for the unit is just linearly regulated to 3.3 volts from the 5-volt input, and this is a USB that's only for testing. Okay, yeah, so we just have a basic USB for testing that I've been using to see that the rest is working. These unpopulated ones are 2512 resistors, and there's a room for a thermistor right there, and this FFC here. The idea is that the power board can regulate the temperature of this board during winter, primarily to keep it from changing too much. And I might add a full case heating as well. We'll see. Now, to mount it inside these slots here, I've got some copper springs here that are soldered down, and on the back I've got a conductive gasketing material. And this has a bit of springiness in it as well, but this is really conductive. And I've superglued this down because you can't really attach it any other way. And so what happens is that you get the DC contact to the aluminium base from the springs, and they also provide preload to compress these against the chassis, and that gets you your AC ground path. So hopefully in not too long these will be installed. It's going to be around 2.5 watts of heating power right near the GPS. You see these, well, they're almost at the GPS. They will heat the GPS up. Next let's take a look at the SURDES board. The SURDES board is fairly simple. There's nothing under the flex here. I've got an extra connector here which has the same pin out as this, and that's just future use. This is a 16-bit SURDES. It felt wrong to only use 4 signals each way. Routing was a little challenging because this requires a lot of space in this area. It would have been more convenient to put stuff here, but whatever. SURDES is there. That's a level shifter. There is power input there as an option, but I'm currently powering it over the FFC cable. On the back there's a lot going on. We have the same solution here for grounding. This is all interfacing circuitry, like terminators and adapters to adapt the ECL logic standard used by this old SFF module to the somewhat non-standard interface used by the SURDES. There's a small micro here, STM32F0, which just controls the SURDES. It also has a UART link to the SURDES on the other side, but it can't talk to anything external. So this basically, in normal operation, will probably just set up the static control signals. I don't think it'll do much more. I probably could have skipped this. But if you need some more complicated logic in terms of getting a link active, then this will be very useful. And here are the sets of LVDS drivers and receivers with common mode chokes and terminators and so on. And we also have linear regulators here. This is 3.3 and 2.5 volts. And you can see the fibers just go in like that. Let me getting the power board out is a little more difficult because it doesn't use a spring. I'll be right back. Okay, so here is the power board for the unit. It's a 9 to 36 or 9 to 30-ish volt unit with a nominal 24 volt input, but this is 9 to 36, but there's a 35 volt cap there. And I've got these nice push-in, I think these might be Vago, not sure, push-in spring terminals, so you just push down there and you can pull these out. I've also got a ground connection for chassis. Under here some EMI filtering common mode choke that didn't quite fit, so I just covered it up with glue after strapping it in place. XP power 20 watt 5 volt generator, and this is the heater driver circuitry. I'm also missing the 8-pin FFCs here, so I can't really use those yet. On the back you got fuse, EMI filtering, bridge rectifier on the input to avoid any major cock-ups at least. microcontroller that I currently can't program to. That's mainly just to drive the heater. You see, you got the high side switches over here, and there's also thermistor sensing by the ADC built in here. Other than that, there's not much going on here. This board just sort of seats in like this. It's not a great solution. Actually came loose in my first take for this recording, so I had to glue it back on. But yeah, it just sits in there. There you go. So let's look at the chassis a bit. These were here originally, but I just put in these spacers to get up to sort of a build height I could put this ground plane on top of. The FC connectors are not in the base, but there's no room in the base for two fiber connectors without doing a lot of work on this unit here. What I did was you notice there are these ejector pin locations in the casting here around the place, so I just used that as the starting point. I drilled in from the back, and then I went in with a cap head screw countersink mill to make a flat here. And there was also a bit of hand touch-up with a Dremel and an end mill. But these are installed, and there's a silicone glue poured in from the back, a very low viscosity type that that will hopefully seal the outside. And I also put some white enamel paint on here to mainly just to prevent corrosion. You see the color match isn't brilliant, but it's good enough. See, this is the connector that I chose. This is a Veipu SF12 3-pin series. This is a push-pull connector with a ball lock, kind of like a Limo, but it's not actually a copy of the Limo style. But basically you can push this in, and this is just microphone cable, 3-pin or shielded 2-wire twisted pair. And so this will go through the pole mount. And unmounting this is not the easiest thing in the world, but it is what it is. It is shielded, it is waterproof, so overall it should be good enough. See, I'm starting to shed my gasket here. It's just held in by grease, so I'm actually surprised it stayed in place that long. Originally there was a plastic collar in here, like a compression collar. It didn't really compress all that well, but I replaced it with set screws, M6 with helicoils for high strength. I'll also say the choice of connector here was mainly driven by the fact that there's like a 15mm bore through the center here. That's where the cable comes out there. And yeah, I needed a square mounting flange that would not have any of these mounting holes go into the bore, because then I couldn't get screws to stay. So it would be waterproof. You see, I've filled some epoxy in here as well. There used to be like a keying location for the original feed through at that location. So I ended up with this. This is the biggest, or this is the smallest connector with a square flange mounting style that will clear the holes. And I can just barely get this out without using hand tools. A smaller connector would not be possible to mount like this. I'd have to make a bushing or something and thread it in there or something. It would be much more complicated. But this connector is good enough, and you know, really, it's not that bad. So yeah, I'll reassemble this, I think, and we'll do something. I don't know. Let's see. I guess I can show you the assembly process. So this goes in like that, and the extra flex is taken up like that. This is my first project using FFC connectors, and pretty happy with them overall. This goes in like that, and not perfectly planned this, but there's enough room along the side here for this to fit there, and then this just sits on top with the M2.5 screws. See? This is my first take on putting these fibers in place, so that's why it looks kind of janky. But it does clear, and it's fiber optics, so it's not a huge deal if these aren't nicely set up. It doesn't really matter. It's fiber optics as long as the bend radiuses are okay, and the bend radiuses here are mostly okay. This part here is not optimal, and there you go. It's basically assembled, and then this just sits along the outside, and currently I've just got this cable coming in from my GPS distribution amplifier to feed this with power, and then it has to sort of sit like this, and let's see, there. You got some lights, and it just sits like that. Hi, this is me from the future, sitting in the editing mansion, as it were, and what I'm realizing with this video is that it really doesn't make any sense why I'd bother building this in the first place, so I thought I'd just explain a bit of why I'm doing this at all. And to start with, we need to go back. Now, I already have a timing system. It's based on the Lucent RFTG-U receiver, which is sort of a dual receiver setup, master and slave redundant system. It was originally made by Symmetricom back in the late 90s and used for presumably CDMA 2G access base stations. And I actually have a couple of those, and they're really good. They have some issues with just because the GPS receiver's over 20 years old at this point. I've had issues with weak rollovers and other issues that I have been able to solve. I also know that they don't really like to output UTC time. They really prefer to output GPS time, and they don't even really tell you what the UTC time offset is, so you sort of have to bake into your programming on your receiver what the time offset is, and then you have to update it every time there's a leap second, or everything's going to be 1 second off, which, for example, NTP will not accept that as valid time if you're 1 second off for some reason. But you can set them to UTC, but then you have to restart them every time there's a leap second. So a couple of months ago, last year, about 6 months ago now, actually, I got a Spectracom Epsilon EC2S, and I made a blog post about this. It's not perfect either. It's pretty good. That's a GPS disciplined oscillator and clock. It has holdover. It's much smaller than my old Lucent setup, being a single unit versus 4 rack units height to mount the Lucent type in a 19-inch rack. I think if you had a 21-inch or 24-inch rack, you could fit them side by side, but that's not possible with standard racks. Anyway, moving along, I was testing the Spectracom clocks, and I realized that they were performing very poorly because my GPS antenna gain was a little low for the receiver they were using. Because of several factors, you need a lot of antenna gain for those receivers to work properly. In my opinion, it's a design mistake, but whatever. It does work if you provide it enough signal. So I already had a 20 dB antenna, and I decided to just go ahead and buy a 26 dB one. And I believe this is the old 20 dB antenna, but the 26 one is very similar. It's the exact same size and envelope and everything. And there's just an end connector in the bottom there. I'm not entirely sure who actually made this, but I think it might be PCTEL. But these were, I think this is the antenna they used with the original Lucent setup. So I bought a 26 dB, and that was pretty good. Actually got me better performance. But while I was looking for those, I came across a listing for this really cute looking little Trimble job. This is a Trimble AccuTime Gold. It is. It's previous generation. And I believe, based on the model number here, that it was probably a Huawei type. I think that's their part number right there. And I got to thinking that, it would be cool to just put this outside, and I could, build something on the inside to, get a frequency out of this. This will just give you NMEA and 1 PPS out, but it is a timing antenna. It's meant for fixed installation. Incidentally, this looked white when I originally was looking at the listing. It's definitely not white now. And while I was also looking, I actually found like the specific unit you're seeing here was also something I found there. And I bought that, and then I bought some more. I bought 2 more. And what I realized was that the connector, you see on the bottom here, that's made by a company called Deutsch. And that connector costs more than I paid for 2 of these. And about as much as this entire thing here with the original cable assembly. So at that point, I was already in the mindset of building a pole mount GPS receiver. And moving along, I realized that, I'd have to replace the connector for this to make sense financially. Otherwise, I could almost buy a brand new kit, right? So I had made several plans and sort of reevaluated a couple of times, dropped some plans and so on. And what I had also been working on at the time was a RF over fiber setup. And that's a pretty cool type of thing. Actually, let me see if I might have one of those. Let me see. Yeah, here's one. This one's, I think it's broken. I think I broke it. This was pulled out of some old GSM base stations. These were used for like a remote feed distributed antenna system. And so I'd already played around with that for a bit and sort of got something to halfway work, Not brilliant, but not awful either. At that point, I figured, why not? Well, I want to do a outside timing antenna. I was still sort of in the mindset of doing it over electrical connections. I'd actually bought cables and plugs and stuff for that. But what I then realized was that actually, I was looking at the product page for U-Blocks because I figured they were pretty good receivers. I noticed they actually had one with a frequency output. So, okay, that's exactly what I want, So I started designing around that, and I realized that, transferring a high frequency signal across twisted pair, or in my case, not even twisted pair, just copper over the lengths I wanted would probably not be feasible. I'd have to, for example, divide it down a whole lot and then resynthesize it at the other end, which would just make things much more complicated than they need to be. So that's sort of how I ended up getting into the fiber aspect of it. I'd already had these SerDes's. I had the SFF modules. Figured, yeah, I could do something with that. Let me show you another thing here. This is one of my, actually the first board I made using this SFF module. This is the same module that's in the GPS right now. And this is made just in a rack blanking plates that I just drilled, and you got your coaxes for transmit and receive. And I actually have this operating. I made 3 of these, and one of these is in fact operational right now, or a pair of them, transferring 10 megahertz from the radio rack to the equipment rack. I used coax initially, but I got a lot of radiated emissions, so there was a very strong 10 megahertz coming in on my shortwave receiver. So that's why I switched to fiber optics when I had the chance. And but at the time, I was thinking I'd move on to higher performance, with that SerDes. That's why I bought it. At the same time that I made these SFF modules, and I've sort of been struggling to find a good use for them. I figured this was, if I didn't do anything with them now, I was never going to do anything, right? I may as well just throw them in the trash. So that's why I've built this using fiber optics. It's mainly just because I already had all these parts and I wanted to do something with fiber optics for quite a while now, since 2016 really, which is when I first built those clock distribution jobs. And yeah, so future plans for this, obviously I'm going to make the indoor unit, and that's going to be pretty cool. And it's probably just going to be a single unit plastic 19-inch case with, I haven't fully spec'd out what I'm going to have in there, but there's going to be a lot of stuff in there. Obviously I'm going to add an NTP server for the Raspberry Pi as well, or with a Raspberry Pi. And so I can have at least 2 Stratum 1 NTP servers on my network, just for redundancy. What I'd also like to redo is an old concept I never actually made a video about, but those old RFGGs aren't only feeding 10 megahertz, they're also feeding timecode and pulse per second to a couple of clocks I have around the apartment here. And there's a custom distribution amplifier I made about 3 years ago. It's been in operation since then. That also has an NTP server built in with the Raspberry Pi, one of the first Raspberry Pis. So I'd like to, I'll probably redo that, but with more experience and skills in designing this sort of thing. I think I can do a better job than I did back then, both on the mechanical side and on the electrical side. So yeah, we're going to be continuing this in the future. I guess keep watching if you find this interesting.